Hi, my name is Rasul, and this is my lab 2 for physical science. So, whenever I first start looking at these words and how I would define them, whenever I look at homogeneous mixture, I think of the word mixture first off. So that means it's not just one thing, it's two or more substances, obviously, but they are very uniform. That's what makes them different from a heterogeneous mixture. It's very uniform, it looks the same throughout. So looking at a heterogeneous mixture, it's obviously two or more substances because it's still a mixture, but with it's not uniform, so it looks different. So that's I think would be the two differences between those. So whenever it comes to the third definition of the third word, solutions, I first think of it as a homogeneous mixture. So it's one thing being dissolved into another. So it's a solvent being dissolved into a solute. So that's the way I think of that. The solute is obviously the one doing the dissolving, like what the particles are being dissolved by. So that's the way I think of that. Whenever I think of suspensions, I think about how it disperses in liquid. So it's basically as two or more substances. For my example, I use protein powder and milk. So whenever you think of suspension, the difference between that, the difference between that and a mixture that is separated by filtration is that whenever you try and separate protein powder and milk, you can't fully separate it. One common thing that you will find is that there will be clumps at the bottom of protein powder and milk. So you'll find clumps of that in order to differentiate between mixtures that can be filtrated. So that's that. Looking at emulsions. Emulsions is basically whenever you have two liquids or two things that should not go together, but there is a stabilizer in there that will bring them together and form a new substance, basically. Whenever you have aerosols, it's basically particles suspended in oxygen. That's the way I would think of it, or oxygen or gas. So whenever I'm thinking about that, that's what I think about. Then question number 2, how are homogeneous mixtures and a pure substance different from each other? Well, I think the main thing is the word mixture. So it is two or more substances that are very uniform, so they look similar, so they have different physical characteristics, but their chemical compound is not the same. And then for a pure substance, I would say that it's just an isolated one substance. That's the easiest way to think about that. So moving on to my examples, a homogeneous mixture. My example, if I look at my fridge here, is going to be milk. So whenever I think of milk, obviously we all think of milk as one thing, but it's different things. So here obviously you read the ingredients, non-fat, ultra-filtered milk, lactase enzyme, vitamin A, palmate, vitamin D3. That's different things combined into one. So you'll have fat swimming around, but at the end of the day, it all looks very similar altogether. And then for my heterogeneous mixture, milk and tapatio. So whenever I'm thinking of a heterogeneous mixture, obviously it's two or more substances. This has two or more substances, but this and this is not uniform together. So that's what makes it a heterogeneous mixture. And whenever I think of a mixture that can be separated by filtration, I look at parsley and water. I look at parsley and water. So at the end of the day, whenever you filter this out, these will stay at the top. Whenever you have like let's say a coffee filter, something like that, it's not going to stay at the bottom like a suspension would. With this is going to separate completely. It's not going to disperse. It's not going to dissolve into anything. So that's my example for mixture that can be separated by filtration. Or another one that I also liked, I just realized, I understood the premise of it, so it was really easy for me to find two things. Orange juice with pulp. So whenever you filter this, the pulp obviously stays on its own. This is a high pulp, so there will be plenty on the top whenever you filter it. So this would be another example of that. So up next, a pure substance. Pure substance would be table salt. So this is sea salt. Obviously, whenever we were trying to differentiate milk and this, obviously this is a different thing. You think of water, you think of H2O. With this, it's sea salt, just sea salt. So it's very simple. I think a way to think about it is just the ingredient list as well. But yeah, that is the definition of a pure substance. Whenever I think of an emulsion, whenever I think that it's two liquids or two some things that shouldn't go together. So for example, water and oil. I would say mayonnaise is a pretty good example of that, because you have, obviously, you look at the ingredients, you have soybean oil, and then water, and then whole eggs, egg yolks. So egg yolks is something that keeps those two together to mix into this. So that was my example, and I feel like that makes sense. Whenever I think of suspension, I have protein powder here, and I also have milk. So obviously, talking about the definitions, whenever you mix these two together, whenever you're filtering through, like if I have, let's say, I have this shaker bottle, if I put both of these in together, I would have to watch out for the clumps at the bottom, because it's dispersing throughout the milk, but it's not dissolving into the milk completely. And it's not filtering throughout, so it's not going to be fully separated. It's just dispersing through. So that was my example for suspension. And then we have aerosol, which is particles suspended in gas. Cooking spray, but it has to be spray because it's mixed with the gas. So whenever it pulls out, whenever you spray it, it's going to come out. So this was my example of that. And I think that's it. I really enjoyed looking through my fridge and pantry and everything for this, so thank you.